All right, here are our charts of oxygen and nitrogen-based functional group and the compounds they make. So we'll walk through these and get an idea of how to name them and what they look like. Start out with alcohols. They're the easiest one. General structure is a long carbon with an OH attached to it. The symbol R is used to represent a long chain, any length of hydrocarbon chain. When I have an alcohol, the ending on the name is going to be OL. For example, we're going to try and use as many 3-carbon compounds as we can, or actually 4-carbon compounds as we can, so you can see how the name changes depending on the type of compound it is. So make a 4-carbon, and we'll stick the alcohol group on the end. The alcohol group can actually go on any of the 4 carbons. So when I have this 4-carbon compound that's an alcohol, 4 carbons is bute, so butanol. Aldehyde, I now have a double bonded oxygen on my end carbon. So I have a long chain. My end carbon is where the functional group is. It's only on the end carbon, and it's a double bonded oxygen. The ending for aldehydes is Al. So when you're writing about alcohols and aldehydes, you have to write clearly. Neat handwriting here is kind of critical. And if you're talking, you need to speak clearly, because Al sounds like OL when you're pronouncing it in a hurry. So here's my 4-carbon chain, double bonded oxygen on the end with a hydrogen, and so same root, butanal. So butanol for alcohol, butanal for aldehyde. Ketone is again a long chain carbon. One of the middle carbons this time has a double bonded oxygen. If it's on the end, it's an aldehyde. If it's in the middle, it's a ketone. And the ending for ketones is O-N-E, kind of like the name ketone. Aldehyde is the al, alcohol has the ol. So the name of the compound gives you a little bit of a clue sometimes about how to name it. So our 4-carbon compound, put the oxygen on one of the interior carbons, and to name it, it's going to be butanone. Carboxylic acid or an organic acid, again, this is an end functional group, just like aldehyde is an end functional group. So we have a long chain. Our end carbon has a double bonded oxygen and an OH. In this case, the OH, the hydrogen in the OH is the acid hydrogen. When I name this, it's going to be the name of the chain, oic acid. So the name tells you it's an organic acid, which makes things nice. Long 4-carbon chain, double bonded oxygen, OH. So when I'm naming this thing, butanoic acid. Ethers are carbon chains that have an oxygen inserted right in the chain. And on both ether and ketone, you may have noticed I put an R prime at one end. That's to designate that the R on the left may or may not be a different number of carbons long compared to the R on the right. And when I'm naming it, I'm going to name the short chain first, followed by the syllables oxy, and then long. So if I put the oxygen in the middle of a 4-carbon chain, and I make it so the chains are different length, I have a short single carbon, so that's going to be meth, oxy, and then 3 carbons is propane. And you can just run that whole name together. An ester is something that we can make in the lab, even here, and it is actually the combination of our carboxylic acid and an alcohol. So I have the alcohol attached to a single oxygen, attached to a carbon that has a double bonded oxygen, and then the rest of the chain. So when I'm naming it, the alcohol portion gets named first, and it has a YL ending, and then the acid portion gets named second, and it has an O8 ending. So if I were to draw this out, and I'll make it similar to the ether, so I have 1 carbon, oxygen, double bonded carbon, and the other 2. So my alcohol portion is here. So that would be the YL ending, so I have methyl. And then my acid part is this end of the molecule, starting with the C double bond O, not including the single O in the chain. And that's 3 carbons, so that's propanoate. So this compound would be methylpropanoate. Okay. These are the oxyfunctional groups. And we have 3 nitrogen functional groups that we're going to take a look at, and that will take us through the final bit of organic. Amine can be anywhere on the molecule. We're going to stick it on the end. Is an NH2 group, almost ammonia, but not, because we've removed 1 hydrogen for forming bonds, and it still retains that lone pair of electrons. So this is an amine, and the ending is amine. This is one where actually you can have the amine be a prefix or suffix. We'll take a look at the 2 ways you can name it. So 4 carbons, and the NH2 group, the amine group, stuck on. So I can call this butanamine. Another way that you can name it, and sometimes it's easier to say or easier to think about, is we put the functional group name first as a prefix, and so I can call this aminobutane. Both are correct accepted ways to name it. An amide is actually a combination of an aldehyde and an amine. So I have the double bonded oxygen on the end carbon, just like an aldehyde, but rather than that hydrogen, I have the amino group. And so this is an amide. So my 4-carbon compound, double bonded oxygen from the aldehyde, amine stuck on in place of the hydrogen, and so butanamide. Butanamide. It's a quick way of saying. The nitro group, again, can be stuck pretty much anywhere, and this functional group is a prefix. So I would name this as nitrobutane. And that is a quick, very quick run through organic, covering the stuff that hopefully you will need to know, and probably more than you need to know, for the upcoming test.